Geeks for Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success. Commit with Geeks for Geeks.
Hello, everyone. Let's see. Let's wait for a few more minutes. So I welcome you back again in the same big data series where we are discussing about the data engineering solutions or how the actual data gets to the data analyst and data scientist people. So welcome back to the series again. Today we'll be seeing how we can analyze the data or how the basic transformation of ETL jobs or like we have already learned how the structure works, but today we'll be learning about how that basic architecture or like how that basic ETL pipelines or how transformed data has been sent to the data warehouse. So that is what we're going to do using the Spark SQL. So let's get started. Let me share the screen. Let me share the screen. Just give me a moment. Now, this is what we have as the clustered Sparks cluster notebook or the Databricks notebook. These are also called as the magic notebooks. Now, we'll discuss about why we call this as the magic notebooks. But now, first, let's discuss about this Databricks. Now, this is what we have as the Databricks, which provides you with uh, enormous possibilities to work with. Now, here you can create notebooks. We have a data import in which you can import any kind of data. It can be in any form, or you can import data from multiple data sources as well. So that is what we have as the data import. Now, then we have the auto ML, where you can apply the machine learning algorithms on a big data. Then we have the transform data. Now, that's a quick learn tutorial. Now, everything works when you talk about Sparks. Now, how it is better than a regular Jupyter notebooks or Collab notebooks? The reason for that is it works on the basis of clusters. Now, I already have created a cluster. Now, what is this cluster? Now, cluster is a cloud platform. Now, not as a cloud platform, it's a resources which we have assigned in the cloud. Okay, so here we have a cloud resource of 15 GBs and 2 active cores, which means we have 15 GBs of RAM available and 2 active cores are available. To process data parallelly, we have 2 cores available. Okay, now that's my login which I've used. Now here the cluster refers to, now this is a community version I'm using. Okay, right now I'm using a community version which allows you the maximum of 15 GB only. But when you go into the part of, let's say, the actual enterprise version, now there you get two benefits. One is unlimited resources. Okay, now we know that in Python it takes almost every data has been processed in the memory itself, right? Every data is processed in the memory. Let me give me a moment. Hello everyone. Sorry for the interruption. Okay, let's get started. Yeah. So we are talking about the clustering part. So on the enterprise version, on the actual business model, when the businesses are using it, we have unlimited resources. Now, as we know, in the case of Python, when we how Python is able to process data so much fast, the reason for that is it is analyzing, it is storing the data into the primary memory. Now, primary memory is what we call it as a RAM or a cache memory, right? And that is why it is able to process data very fast. Sorry for the interruption. Give me a moment. Sorry for the interruption. Okay. So, as we discussed, that to process the data, we Python uses memory in memory consumption, or it uses the primary memory itself. So in this particular case, now here also, Sparks can also process data in memory or in the primary memory. But obviously, in a laptop, we can have a memory or a RAM of around 16 GB or maybe 32 GB, or nowadays we have a 64 GB RAMs as well, 64 GB or 128 GBs as well. But the data we are dealing with nowadays is even bigger than that. To process that much huge kind of data, that's when we need to go with this clusters. Now, what is the benefit of this cluster is that you can connect multiple systems, multiple operating system, multiple resources, and you can borrow multiple resources from the cloud also. So you can easily scale your system, you can easily scale your machines. So here we are using a community version, that's why we have a 15 GB memory only. But if we go with a bigger one, like if I just go with a create commute, now here I can provide a cluster name. So let's say Sparks SQL. Now here you can see it's 15 GB of instance, but when we have a upgrade this database subscription, we can increase that size. Okay, so I have already have created this one. Now here you can see it's using a Scala. Now Scala, why it is called as Scala? Because the primary language on which the Sparks has been created is the Scala. You can work with Python also, you can work with R, SQL also, but the primary language which it works with is the Scala. Okay, so that's how you can create a cluster. Once the cluster is created, this is how it will looks like. Now in this cluster, when you connect a notebook, which I've already connected, so let's reconnect the notebook. So you can create a new notebook. Here you can see it automatically detected it. But if you want to connect multiple notebook on the same one, from here you can choose whichever is the running cluster. Now here we have only one running cluster, so we are connecting this notebook gets connected to this cluster only. Okay, now let's analyze how we can work with this data, or use this notebook to analyze the data. So first is that we need to create a table. Now either you can use it using this table method, or because I've already uploaded a CSV file into this one, which is a airports data. So I'll directly use this CSV file. Now the command goes the same way as we used to do it in the case of Spark Python. Like data frame is equal to, now we'll be using a sparks dot read, that I want to read dot format. Now in this format, I want to read a CSV file. So we mentioned a CSV file dot options. Now option refers to like headers. Like my file is gonna have headers, so I can pass headers equal to true because it contains headers, and similarly the schema also, that if you want to apply a different schema, you can go with that also. But whatever is the schema available within that structure, just go with that. So for that reason, we are providing it as true dot. Now where is that file available? So we just load it with the help of file store. Okay, so here we have is the, now every file which you're uploading is getting into the file store slash tables. Now if you want to check out where is that file, or what we do is we put a percentage fs. Now it's a filing system. Okay, we have entered into the part of filing system to access or to work with any kind of files whichever you have, to utilize the files. That's why we are entering this particular domain or into this particular command. That is what like percentage fs means. Now what is the benefit of this percentage fs is that if you want to check out the filing system of this particular place, that's when you can use it. Okay, so if you want to check out, what we can simply write is fs and the file store, like the regular which we have is slash, sorry, ls, no, ls, no, ls is command minus l file store slash tables. Let's run this. Now these are the filing or the command line prompt commands. There we made some error. Macro. Need to put a slash out here also. Let's see what is the two. Okay, we'll fix this one later on. We'll see. But this is how you write the command as file store, because to access the particular file, we provide it as a file store tables. Now within that table, I have a file name as airport. Airports 2 csv dot bz25. Now what is this bz2 extension? Now bz2 extension is a highly compressed extension which we use to compress your csv files into very smaller size. Now it have a lot of values, and by default the size is around 200 MBs approx. But when we compress it using bz2 compression, it get compressed into like 1/10 of it. Now this file is highly compressed, so we'll use this df.show. So if I go with this particular one, we got some error, file storage, table cluster. Okay, it's files. Okay, so earlier also it was a mistake. Slash here. Now it's running. And here also it was a mistake with this spelling part. So now because we are using a cloud system and we are utilizing a lot of resources, so that's why it is going to take some time. So let's wait for a while. Let it get executed. Okay, so now now you can see the above command also ran very well. Now you can see multiple data files are available in this file store. We'll discuss about different parts. Now here you can see this is what we have as the data, where you have origin airport, destination city, origin city, destination city, passengers traveling, seats, flights, distance, flight date, and origin population, destination population, and so on. So this is all the data which we have. Okay, now let's see how we can use it using the Sparks, or how we can work with this particular data using Sparks. So let's go with the new cell. Now here, this is what we call it as a magic notebook, as I mentioned earlier. Now, why is it called as a magic notebook? Reason why it is, because here you can see you are working with the filing system command. Now, by default, it's a Python notebook, which you can change it either to SQL, Scala, or R, because Sparks supports all 4 languages. Now, by default, we have set it to the Python, which means every command, every cell which you're going to use is going to be written in Python only. But suppose in this Python notebook, now I want to, let's convert this table first. Now, first, let's convert this into a delta lake with column as maybe, let's say, which can be the column. You can pass any column, let's say it will be flight date. It is flight date. Now in this flight date, what I want is, let's import the functions of SQL also from PySpark. So we are importing everything. So we are importing the star, and then here what we're going to do is we're going to use this column flight date, and we have to update the values, because if you check out for the data type, like how we can check out the data type is that, let's remove this part, we don't need it now. Let's directly write it to the delta format. Right dot format we have is the delta. Now we have discussed about 2 different types of format, because when we read a table, it is always read in the horizontal way, and the benefit of that is that you get with easily writing part and reading part both. You can easily write data in it, and you can also read the data in that same table itself. But when we use the delta, that is what we refer to the same. But and similar to that, we have a Parquet format. Now the benefit of Parquet is that you get very faster speed in the reading part. The main benefit of it is that we have increased speed of reading with respect to the Parquet format. That was the benefit of it. So mode is overwrite. So if there is any file available with the same name, we're just overwriting it. So it will not give us an error. So mode is overwrite dot option. Now in that we are just overwriting the schema. Writing schema, that is true. Dot, we have saved this table as save as table. Let's say airport. Let's say to be airport data. Let's run this. You are so expected. That's right. What is the error? Let's simply remove this part if it not work. If we have already available itself, let's say it be our data SQL. Now the data has been saved, is been getting saved into the form of delta format. Okay, so we are saving the data, the which you already created, which is this df, Now we are converting it into a delta format of airport data underscore SQL. Okay, so once the data has been created, now let's see how we can analyze it and how we can create a ETL part for the same. It is taking some time because we are dealing with slightly bigger data. Now, this is the data we already have till the time we can talk about this part. That this is the data we have. So, what are the possible ways of analyzing this one using this Sparks? Now, this benefit of it, like if we have to think of, suppose which is the longest flights or which cities have the longest flights. So, if we have to figure out that one, what we can simply do is we can write the command as like, okay, so the table has been created. Now to use a SQL command over here, what we have to simply do is percentage SQL. Now you can use a simple command as select star from airport data SQL limit 5. Now if you simply run this command, you get top 5 entries of this data itself, and you can see you are easily able to run a SQL command for it. Okay, now let's see it. Let's try to further analyze it, and let's go with the question. Now if you want to put a markdown, you can give it MD, percentage MD. Now here I can simply write as analysis process. You can see analysis. Now let's start with which cities have which, because we're going to use SQL. So let's go with the SQL part. SQL. Suppose which cities have the longest flights. Now how we can do it? So we are using a CTE table, which is CTE query airport origin airport. Now that's the syntax of you writing a CTE query, which is a common table expressions. Now here we are creating a template. We are creating a table which can be then utilized again into the next table itself. Okay. So first, what we are doing is, if we have to figure out like all the let's say longest flight. So longest flight will be like airport, origin airport, destination airport, and the distance between them. So that is what we're gonna rank, right? So we have a distance available, we have an origin and destination. So we're gonna select origin airport, destination airport, and distance. Now we're gonna rank them. Now it's a window function. Rank is a window function. So we need to create a window which is rank over. Now what was the possible way of doing it? So we are partitioning it to have a better performance. Partition by. Now we can do it using origin airport because that's the main motive. You can do it the partition more different ways also, but we are doing it this way. Order by distance in descending order because we need the highest one first. So that's the partitioning as rankings. Now this will be giving you the ranked values. Now what we are going to do is we can simply just close it and mark it as okay, from this airport data .sql. So that is where the first query ended. Okay, now let's we need to complete it. So here we are going to write is select star from, or let's say to be select distinct origin airports. because we have to provide the origin cities. So it's origin city or origin airport from this table. Let's say it to be origin airport. Let's say that to get the distinct origin airports, we got some error near the rank. Okay, we didn't put a comma over here. That was a missing value. Now it's running fine. Now this is what we have as the rankings. Let's say it to be star to get to see everything. Star from origin airport. That will print us all the origin distances along with the distance and the ranks. Now let's see it. So you can see. So for the distance part, these are the highest one for each and every destination and origin pairing. Okay, now for this is the first one. Second one is what we have is the highest origin is. This is the one with the second one. So this is what we have as the distances, like the longest flight distances for each and every city. Like for this city, this is the longest flight available. That is what we are analyzing using the Spark SQL. And because it's around, and if you check out the size of this data, like the total size, we didn't discuss about the total size. So select star from airport data SQL. Sorry, count star, it should be count star from airport. SQL. Okay, we need to make it as SQL command also, because right now it is a Python command. So let's make it as SQLs. Now let's run it. So you can see it have 36 lakh rows. Okay, it is having a 36 lakh rows. So you can imagine what is the size of this data. Okay, so it is having 36 rows of entries, 36 lakh rows of entries with that many number of columns. So that is why processing does take some amount. And here you see with each and every command which is running, you're also getting the time utilized by the same. Okay, and that is how you try to analyze your data. Now let's go with another option, that which is the highest longest cities. Suppose if you want to figure out which was the busiest and the slowest day, and how many flights did fly in that particular day. Now how we can get that? So what we can simply do is, again, making this as a SQL cell. Now it's a SQL cell. Now in this one, what we have to find out is first the busiest and the slowest day, right? Which is the busiest and the slowest day available, and how many flights did fly on that particular day. So how are we going to figure out? So select fly date, comma, count of flights, right? So count of flights can be done by using flight date also, right? We're just finding the flight count only. Flight date as the numbers, yeah, like flight as number of flights, the number of flights from that airport data.sql. Now obviously because we are using aggregate functions, we need to go with the group by flight date, group by flight date, order by, again, the count itself, which is number of flights in the descending order. So that is going to be the busiest day, limit 1. If we run this, we get now this is the busiest day whichever we had, which is 2007, 12 and 1. Like year 2000, December 1. So that is the busiest flight day which we had. Okay. So that is how you can analyze multiple things, multiple operations in this SQL language or using this Spark SQL. And similarly, you can write up many more other queries also as per as you want. Now let's see one more difference. Like as we discussed, that with the help of Parquet, you are getting it faster. So if we convert this in a Parquet format, and if we rerun this SQL Parquet, now what is this Parquet format basically? It's very commonly used uh, format which we generally use when you are dealing with a very big data and you want to keep this data for the analysis purpose. In those kind of cases, this is very popular format, which is Parquet, which increases your reading speed by up to 10 folds or by 10 times. Now the processing will take time, but the later on speeds will be much faster. Okay, so it worked. Now let's see this data set. How well or how fast is it working? So suppose if I look out for a particular value, let's apply it in this one. Now it took originally as 3.29 seconds. If I run this with this one, initially it might take a little time. Like you can see it was much faster, but when you rerun this one, it will be much faster than the earlier one. You can see 2.2 seconds. So the Parquet formats are much more faster compared to the original Delta formats. That is the reason why we use the Parquet formats to make things much more faster in the readability part. So original Delta format time was 3.2 something, and here it is 2.20. As you'll keep on reusing it, it will keep on improving the speed also. So that is the benefit of using this Parquet format over a Delta format. And initially we said that the table which you are creating is a delta lake. Now what is a delta lake? So as we know that we have a data lakes available. Now the first thing to start reading the data, or the first step of reading the data from the data lake, is what we refer to as delta lake. That you're converting your data which is stored in a CSV files or in any kind of file in any of the format into a data lake. You start picking them one by one and start converting them into a delta lake. That is what we refer to as delta lake. And that is where mostly it's been converted as a delta lakes, because we are formatting our data, we are cleaning our data. And Parquets are the final format, which is done after all the cleaning and everything. Okay, so that is what we have as the Parquet format. So that is how you use this particular scenario. That is how you use this online cloud platform to analyze your big data. And if you want to store it somewhere, if you want to just store this data, so for that you can provide a location of storage, and everything gets stored into this data lake or into a data warehouse as well. And that is how we utilize this. I hope this session was we are good and we had a good understanding of how to use the Spark cluster and how we use the magic notebooks. So that is all for today. Thank you everyone. If anyone have any question, query, doubts, please let me know. Okay, so I guess that's all for today. Thank you, everyone.